Okay, hello, assalamu alaikum. Welcome to another review. I hope you can hear me clearly. Anyway, so we're doing a review for quiz 3, and it's going to be on bonding in the periodic table, and those are the pages that will be that you will be tested on. Okay, so what I'd like you to do is please be ready, answer the questions before I do, and then see if you get them right. If you don't get them right, go back through your notes and listen to the explanation as well. All right, let's go. So let's have a look. I'm trying to keep this as short as possible. Multiple choice questions. Which type of element is found on the right side of the periodic table? Okay, so where is the right side of the periodic table? Well, let's have a look. This is the periodic table. Oh, that's massive. Let's make it smaller. As you can see, there's the left side of the periodic table. That's on the left. That's the right side of the periodic table. So which elements are found on the right side of the periodic table? Those are the non-metals, okay? So things like nitrogen, oxygen, neon, chlorine, all of these are non-metals, okay? So that's the first one, non-metals. Which elements often act as a bridge between metals and non-metals in their properties? So when it comes to properties, it's very clear how metals behave and what their properties are. So metals are malleable, ductile, conductive for both heat and electricity. Metals have high melting and boiling points. Metals are hard. Metals are sonorous. Metals are shiny and lustrous. Non-metals are brittle and dull, and they don't conduct heat and electricity very well. But then we've got this group of elements over here. Whoops. We've got this group of elements over here that are sort of between metals and non-metals, and we call these metalloids. Okay, we call them metalloids. So let's go back to the question then. The question says, which elements often act as a bridge between metals and non-metals and their properties? And those are metalloids. The property that allows metals to be hammered into thin sheets is called what? So whether it's hammered into thin sheets or whether it's shaped, that is the malleability of metals. Metals are very malleable, which is great because then we can make all sorts of things with them. So here I've got a wire, I've got a thin wire, and what I can do with it is I can bend it and shape it, and I could turn it into a paper clip if I wanted to. That's because metals are malleable, and I can hammer it into shape. I can make jewelry out of it. I can make a can out of it. I can make my scissors out of it, right? So all of these are made because of the property of metal that it's malleable. So malleability means we can shape metals, we can hammer them into shape. Which group of elements is the least chemically reactive? Okay, so if you remember, the ones that are least chemically reactive are the ones with a complete outer shell, the ones that have a full outer shell of electrons, and those are group 8 metals, non-metals. Those are the noble gases. So this group right here, those are the least reactive, and the reason why they are least reactive is because they don't need anyone. They don't really need any electrons from anyone. They're just happy the way they are. Okay, so let's keep moving. Which group of elements is the least chemically reactive? We said those were the noble gases. Alkali metals are very reactive metals. Halogens are very reactive nonmetals. Noble gases are not reactive. Okay, and transition metals, well, they have differing reactivities. An element that can conduct electricity only under certain conditions is called what? Now, the key to answering this question is this part here, only under certain conditions. So what this means is it doesn't conduct electricity all the time, only under certain conditions. So what we're looking for here is a metalloid. That means, yes, metals do conduct electricity, and yes, nonmetals don't conduct electricity, but now we're talking about a set of elements that conduct electricity, but only under certain conditions. And those are the non-metals. The metalloids. Metalloids. Moving on. Which of the following describes most non-metals? So let's go through these. Shiny, good conductors, that's metals. So that's definitely not non-metals. Dull and brittle, yeah, that's non-metals. But just for fun's sake, let's keep going. Ductile and malleable, that's also metals, because remember, ductile means they can be drawn into wires. and malleable means they can be hammered into shape. So that's definitely not nonmetals. Found mainly on the left side of the periodic table. Once again, that's metals. Metals are found mainly on the left side of the periodic table. So the answer is B. Valence electrons are important because they do what? Valence electrons are the electrons on the outside. So if I'm to draw lithium, lithium has 3 electrons. So there's 2 on the inside and there's 1 on the outside. This one here, this guy, is called a valence electron. Okay, so the electrons on the outside shell in the last energy level, in the last orbital, whatever you want to call it, those are called valence electrons. Okay, so with that out of the way, valence electrons are important. Why are they important? They're the ones used in chemical reactions. This is what makes alkali metals so reactive. The fact that they have 1 electron and they really want to get rid of it. Whereas alkaline earth metals have 2. They kind of sort of accepted their fate a bit. They kind of thought, well, I've got 2, I've got to get rid of 2. So they are reactive, but not as reactive as alkaline metals. What about halogens? Well, if we look at the halogens, that's group 7. They're reactive as well. The reason being because they just need the 1 electron to complete the outer shell. So this is not an explanation lesson, but I can't help but explain just a few facts. If you would like a more extensive explanation of this lesson, please feel free to click on the link below in the description. That is the complete lesson. Okay? So valence electrons are important because they are involved in chemical reactions. That's why they are important. Okay, they're not found on the nucleus. They don't affect chemical reaction. They certainly do. Okay. Compared to metals and nonmetals, how do semiconductors or semiconductors behave? They conduct better than metals in all conditions. Absolutely not. So metals are obviously conductive. They never conduct electricity. That is also not true. They do conduct electricity, but only under certain conditions. They behave like insulators at low temperatures, but conductors at high temperatures. That is a true statement. And they are always more reactive than halogens. That's also not true. So the one true statement there is that semiconductors or semiconductors are a special group of elements that behave like metals under certain conditions and like nonmetals under other conditions. So mainly to do with temperature and sunlight or light. So sometimes they'll behave like insulators with low temperature or without the presence of light, whereas with the presence of light and under high temperatures, they can behave like conductors, like metals, and that is quite useful. Okay, which property of gold explains why it's used in making jewelry? Okay, so if you look at jewelry, obviously jewelry is very shiny. Okay, so that's very attractive, very shiny. But what else? It's also malleable. So if I'm to think about gold, what property makes it useful for making jewelry? The fact that it's malleable, that it can be hammered into shape, that it can be shaped, and the fact that it's obviously lustrous, which means it's shiny, makes it look pretty. And we could also say that it's rare, but that's not exclusively a metallic quality. So let's have a look at the options. That will help us answer the question. Which property of gold explains why it's used in making jewelry? Is it the luster? Is it the high density? Is it the conductivity? Or is it the high reactivity? Now, I want you to be very careful answering these questions. Yes, gold has high density. That is true. It does have high density. And yes, gold is highly conductive. In fact, it's a very good conductor. It's not highly reactive at all. In fact, it's quite stable. But just because these two are true doesn't mean they are the correct answer. Gold is lustrous, it's shiny. Gold is highly dense, and gold is conductive. So which one is the correct one? Well, we have to look at the question. It's used for making jewelry. Which one is important for making jewelry? High density? I don't care that it's highly dense. In fact, if anything, that'll make the jewelry really heavy. And maybe some people like that, maybe some people don't. But that's not really the quality I'm looking for when I'm making jewelry. What about conductivity? Once again, that's not important in making jewelry, right? If I'm making a necklace or if I'm making a ring or some earrings, is that really that important? The most important part here is the luster, the fact that it's shiny and looks pretty. Okay? Which set of elements is placed in the center block of the periodic table? So remember, the center block is this guy here. Let me just show you. This is the periodic table. This is the center block. So what are we talking about with the center block? We are talking about transition metals, of course. So those are transition metals. So here we go. Let's just, where is it? Here we go. Transition metals. Let's move on. True and false, or true or false. Metals are generally good conductors of heat and electricity. Absolutely, that is true. Metals are good conductors of heat and electricity. Elements in the same group have similar chemical properties. That is also true. Same group, same family, same column. So remember, group is also known as family or column. Noble gases are highly reactive and easily form compounds. That is false. Okay, noble gases are actually not highly reactive. They are stable. So they're definitely not highly reactive. So if I was to think I have to replace this word with another word, not noble gases, I could replace that with alkali metals. Okay? Or I could replace it with halogens even. But I'm just going to choose to replace it with alkali metals. Alkali metals are highly reactive and easily form compounds. That's now better. Nonmetals usually have lower densities than metals. That is also true. Nonmetals usually do have lower densities than metals. In fact, many of them are gaseous. The ability of a metal to be drawn into wires is called malleability. No, not quite, although they are related, but it's called ductility. So it's not malleability, it's actually being ductile. Ductility. Okay, so that's also false. Okay, let's move on. Cross out one of the options so that each sentence reads with the correct answer. Read the question carefully and understand what the question is asking of you. So in this case, they want you to cross out the bad option. Okay, so how do we do that? Basically, just put a line through it. That's what they're asking you to do. So metals cannot usually conduct electricity. I know it's tempting to just do that, but that's not what the question's asking for. It says cross out the bad option or the option that is not correct. So metals, so you just have to do that. Can usually conduct electricity? Absolutely. Non-metals usually conduct electricity. Well, we know they cannot, so I gotta cross out the can. Metals are good what of heat energy? They are good conductors, so I've got to cross out the insulators. Non-metals are good. Non-metals are good what of heat energy? They are good insulators, so I've got to cross out the conductors part. Metals are what when polished and freshly cut? They are shiny. Metals are they brittle or malleable? They are malleable, which means they bend. So I've got to cross out brittle. Metals have what melting and boiling points? Do they have high melting and boiling points or low melting and boiling points? Well, obviously they have high melting and boiling points, which is why we use them as cooking utensils, because they can withstand high temperatures. So I'm going to cross out the low part. And non-metals have low melting and boiling points. Okay, nearly there. Explain using the properties of metals and non-metals why the cooking pan is made of metal while the handle is made of plastic. Well, that's an interesting question. The reason why the cooking pan is made of metal, cooking pan, pan is made, oh my goodness, my handwriting, of metal, so it can conduct heat and pass heat to, oh, pan looks horrible. Let me just fix that. Oops. Oh, I'll just leave it. Oh no, I can't leave it. There is a way. That's the best I can do. Okay, pass heat to the food. So a cooking pan is made of metal, so it can conduct heat and pass heat to the food. Because obviously, if it was a non-metal, the food could not get the heat and we couldn't cook. But we also want to protect our hands. The handle is nonmetal. Oops. So our hand is protected. Oops. Our hand remains protected from the high heat. Okay? Something to that effect. And let's have a look at this. Draw the electron dot diagrams for the following elements. You may need the periodic table. Okay, very good. So I've got sodium here. Now remember, sodium has this symbol here. So there's sodium. If you're not sure, look at the periodic table, find sodium. There's sodium. And in order to draw the electron dot diagram, there's two ways. So one way, I can just look at which group sodium is in. So it's in group 1, and that's group 2, and that's 3, 4, 5, 6, 7, and that's 8. So sodium is in group 1, so sodium has one valence electron, and I can draw it like that. Or if I want to, I can draw it like that, or like that, or like that. It doesn't really matter where you put the electron as long as you put it somewhere. So there's sodium. Another way I can figure out how much or how many valence electrons sodium has is by looking at the proton number or the atomic number. Sodium has 11 protons, which means it has 11 electrons. And so this is what sodium looks like. It's got 2 in the inside. It's got 8 in the next level. And then it's got 1 on the very outside. Oops. It's got 1 on the very outside. But you don't have to worry about this. All you have to do is look at the group number. If it's in group 1, it has 1. Okay? And everything in group 1 has 1 valence electron, just like everything in group 2 has 2 valence electrons, and so on and so forth. So that's sodium with its 1 electron. What about nitrogen? Nitrogen, it's over here. What group is it in? Have a look. It's in group 5. So this is nitrogen. 1, 2, 3, 4, 5. And remember, it doesn't matter where you put the electrons. I can do this instead. Okay, that's also correct. What about bromine? Bromine is in group 7. Over here, there's bromine, group 7. So it has 7. Bromine. Remember, the second letter is always small. Please don't do this. I know some people do that. That's not the same, okay? Make sure the symbols or the chemical symbols are written correctly. It has 7. So 1, 2, 3, 4, 5, 6, 7. Or if you prefer, you can do that. Okay, or if you prefer, you can do that. Okay, that is it. I wish you the best of luck. Take care. Over and out.